Now consider this example. We have to find out all values of this, means we have to find out the roots of this equation or root of this complex number. First we have to and further question is, hence show that their continued product is 1. But we have to find out root of this complex number, and we have to take a product of all these roots, and we have to show that it is a answer is 1. Now first we have to convert this complex number into polar form. Okay, therefore z is equal to r cos theta plus I sin theta. This is a polar form. Value of r is nothing but under root of x square plus y square half square plus root 3 by 2 square. Answer is 1. And this point half root 3 by 2 lies in first quadrant. Therefore theta is nothing but, by our usual notation, tan inverse y upon x. That is tan inverse root 3 by 2 upon half, which is tan inverse root 3 is pi by 3. Therefore z is equal to r cos theta plus I sin theta is nothing but given complex number cos pi by 3 plus I sin pi by 3. Okay, therefore consider this complex number, which is equal raised to 3 by 2 as it is, as given in the example. Cos pi by 3 plus I sin pi by 3 raised to 3 by 2 as it is, 3 by 4 as it is. Now uh, in this indice 3 is a cube and 1 by 4 is a root. Therefore 1 by 4 we have to find out 4 roots only. Before that we have to take 3 inside as it is. Therefore take 3, that is cube, whatever the number in the numerator we have to take as it is in the inside the complex number. Therefore we get cos pi, 3 gets cancelled, plus I sin pi, rest to 1 by 4. Now it is our usual notation, fourth root. We have to find out 4 roots of this equation. Therefore add again De Moivre's theorem. Here before that we have to add 2k pi to the angle, and again 2k pi here also same for cos and sin. And then now apply De Moivre's theorem. 1 by 4 get inside to this angle. Value of k should be, total number of roots should be 4. Therefore k start from 0, 1, 2, 3. Now go on putting value of k is equal to 0, we get first root. K is equal to 1, 2, 3, we get these 4 roots. Total 4 roots we get. Okay, now this is the first question, first half question we have completed. Now second question is, we have to take continued product of these 4 roots. Therefore consider x1, x2, x3, x4. Continue product. Put as it is the values of these roots. Now we know one result. Product of all these complex number is nothing but cos of addition of all this complex number plus sign as it is I sine of same angle addition of all these angles. Okay, now add these all angles, we get 16 pi by 4, that is 4 pi plus I sine 4 pi, and we know cos 4 pi is 1, sine 4 pi is 0. 4 pi means 4 into 180 degree. You can calculate by calculator also. The answer is 1. Okay, now these are some homeworks. We have to solve x raised to 6 plus 1 is equal to 0. We have to find out 6th root, and this is again we have to solve x raised to 7 minus x raised to 4 minus x cube plus 1 is equal to 0. We have to find out 7 root of this equation. Now consider, if alpha, alpha square, alpha cube, alpha raised to 4 are roots of this equation, x raised to 5 minus 1 is equal to 0. This is given thing. Okay, these are 4 roots of this equation we have given. There are total 5 roots, and out of 5 roots the 4 roots are given in the terms of notation. Okay, we have to show that 1 minus alpha, 1 minus alpha square, 1 minus alpha cube, 1 minus alpha raised to 4, value of all product is 5. Okay, consider this equation. First, x raised to 5 minus 1 is equal to 0. We have to solve this equation to find out the roots, and accordingly we have to recognize what is alpha, what is alpha square, what is alpha cube, and what is alpha raised to 4. Then x raised to 5 is equal to 1, and x is equal to 1 raised to 1 by 5. Instead of 1 we can write, now theory of root is root starts here. Cos 0 plus I sin 0, value of 1 is this, raised to 5. Add 2k pi to this angle before taking 1 by 5 inside. Now take 1 by 5 inside using De Moivre's theorem. And value of k is, total number of roots are 5, therefore 0, 1, 2, 3, 4, 5. Okay, go on putting value of k is equal to 0 here. We get x1 value, cos 0 plus I sin 0. x1, first root is 1. Already we get 1 as a root of this equation, first root. Now k is equal to 1, we get x2, that is cos 2 pi by 5 plus I sin 2 pi by 5. And we call it as 1 alpha. First root, that is alpha. We have given these are the roots. This is alpha. Now put k is equal to 2, we get x3 third root cos 4 pi by 5 plus I sin 4 pi by 5. And we have to convert this into alpha as again De Moivre's theorem. Take out of this 4, take 2 only on indice using De Moivre's theorem only, and this is comes to alpha only, and this is equal to alpha square, which is our second root as it is. Okay, third root actually. Now put k is equal to 3 here, we get x fourth root cos 6 pi by 5. Out of 6 pi by 5 we have to take we have to put in the bracket 2 pi by 5, and remaining indice is 3 as it is, therefore this is again alpha cube. Similarly k is equal to 4 cos 8 pi by 5, which is cos 2 pi by 5 raised to 4, De Moivre's theorem. And this is alpha again, alpha raised to 4. These are the 5 roots we get, 1 alpha, alpha square, alpha cube, and alpha raised to 4. And what we have to prove, this 1 minus alpha, 1 minus alpha square, this product is equal to 5. Okay, now observe these two. If we get alpha, alpha square, alpha cube, alpha raised to 4 are roots, then, and 1 is also root, then x minus 1, this 1, x minus this alpha, x minus alpha square, x minus alpha cube, x minus alpha raised to 4, these are the factors. Okay, if 1 is the root, suppose, then x minus 1 is the factor, we know. In that case, in like that only, these are the factors of given example. These are the 5 factors. Okay, now if these are the factors of this original equation, therefore we know this equation is nothing but product of this all these factors. This is but obvious. Okay, now observe these two. Therefore x minus we have to find out this term, 1 minus alpha, 1 minus alpha square. The total 4 terms are there. Therefore out of these 5 terms, x minus 1, take it on LHS side. What we get, x minus alpha square, alpha cube, and alpha raised to 4 is equal to x raised to 5 minus 1 divided by x minus 1. Okay, this we have to take as it is. Now we have to put x is equal to 1 here to get 1 minus alpha square, because 1 is a root of this equation. If in this equation we put x is equal to 1 here, we get infinity value. That's why we have to solve this RHS side equation by doing proper division of x raised to 5 minus 1 divided by x minus 1. This as it is, x raised to 5, just multiply x by x raised to 4, we get x raised to 5 term. Therefore first term is x raised to 4 here. Now multiply x raised to 4 by x minus 1, we get this, and subtract this. This is a usual division method. Okay, we get x raised to 4 minus 1, remainder here, first remainder. Now multiply x by x raised to cube, we get x raised to 4. Therefore second term will be x cube. Multiply x cube by this, we get x raised to 4 minus x cube. Now subtract this, we get x raised to 4 cancel, value x raised to cube minus 1 remaining. Go on doing this division up to we get remainder 0 or power of x less than this. Okay, we get last term x minus 1, and x minus 1 into 1 is x minus 1, remainder is 0. Therefore value of x raised to 5 divided by x minus 1 is nothing but this term, equal to this. Okay, now put x value 1 in above equation. What we get, 1 minus alpha, 1 minus alpha square, alpha cube, alpha raised to 4 is equal to 1 plus 1 plus 1 plus 1 plus 1, that is 5. Okay. Now consider this next example. We have to solve. This is a very easy example. You can solve by your own. X raised to 10 plus 11 x raised to 5 plus 10 is equal to 0. We have to find out 10 roots. Okay, this is the question. Solve. Now factorize this term as 11x raised to 5 as x raised to 5 term plus 10x raised to 5. Now common 10 out of these two terms and take common x raised to 5 from these two terms. We get x raised to 5 plus 1 again common from these two terms. And we get two factors of this original equation, that is x raised to 5 plus 1 is equal to 0 and x raised to 5 plus 10 is equal to 0. These are the two factors of this equation. Therefore total 10 roots we have to find, 5 roots from here and 5 roots from here. And from this this is very easy, as earlier we can solve this, that x raised to 5 plus 1 is equal to 0, x raised to 5 is equal to minus 1, x is equal to minus 1 raised to 1 by 5. Solve as earlier. Okay, now this, consider this is a new thing. X raised to 5 plus 10 is equal to 0, that means x raised to 5 is equal to minus this number 10. In note we have only 4 numbers, that is 1, minus 1, I, minus I. Apart from these 4 numbers, if any number is there in the equation, then split this number as this 10 or whatever number into this minus 1. Okay, now take 1 by 5th root on both sides. We get x is equal to 10 raised to 1 by 5, 5th root of 10 is 2, and minus 1 raised to 1 by 5. And this again we can solve as earlier, cos pi plus I sin pi raised to 1 by 5. And in every step this 2 must be constant. Okay, in this case we get 5 roots from here and 5 roots from this equation. Now next example, prove that, we have to prove that nth root of a plus ib, this is one complex number whose nth root, square root of this is n means nth root, plus nth root of a, this is complex conjugate of a plus ib, nth root of a minus ib has n real values, means n real roots, and hence find those of this, means we have to find n real values of this, n real roots of this, and apply this theory for this example by putting a is equal to 1, b is equal to root 3, n is equal to 3. Okay, first consider, we have to consider this example. R is equal to, suppose we have to convert this complex number into polar form. First, let R is equal to under root of a square plus b square, value of this complex number. This is nothing but, our example is nothing but this. Okay, we have to find out this value of these roots, roots of these equations or root of this term. Okay, that means we have to find out first complex number, polar form of this complex number, and just apply plus to minus sign, we get polar form of this complex number also. Now complex number r, we have to find out a square plus b square, theta is nothing but tan inverse b upon a. Okay, therefore a plus ib is nothing but r cos theta plus I sin theta is a polar form, and a minus ib is nothing but r cos theta, just replace plus by minus sign here. This is a polar form of these two complex numbers. Okay, now consider nth root of this first polar form, that is nth root of a plus ib, which is given in the example, which is equal to r cos theta plus I sin theta raised to 1 by n. Again r is a real number, take outside, r raised to 1 by n, and cos theta plus I sin theta upon raised to 1 by n, and this is again a root of n root of this equation. Therefore apply root theory here, add 2k pi to this angle and take then 1 upon n inside this angle. Now how many roots are there? N roots are there. Therefore k value start from 0, 1, 2 up to one number less than n, that is n minus 1. Similarly, this is the roots of this. Go on putting value of k, we get n roots of this complex number. Similarly, for this complex number, we can write it similarly. R raised to 1 by n is same. Just replace plus by minus sign here. Roots are same. N minus 1 roots are there for this equation also, for this complex number also. Now add these two. What we have to do? Addition of these two. The example addition is there. Therefore add about 2. What we get? If we add this, r raised to 1 by n gets common. Cos term gets 2 times and sin term gets cancelled. As it is, one is plus, other is minus. Therefore it becomes 2 r raised to 1 by n cos of 2k pi plus theta upon n. K values are same, 0 to n minus 1. This is the answer for first. Now we have to find out other question. These are the roots, obviously. We don't need to put values of k because we don't know what is a, what is b. This is general form. I keep it as it is. Now put values of, this is a hence question. We have to solve this using above theory only. We get n roots of this equation, this complex number. Now put value of n is equal to 3, a is equal to 1, b is equal to root 3 in this equation. What we get? Therefore a, b, c, a, b, n values are there. R value as it is 2, 1 plus 3. Theta is tan inverse root 3 by 1, that is pi by 3. Therefore this addition is nothing but 2 into r raised to 1 by 3 cos of 2k pi plus pi by 3 upon 3. Put this value as it is in the earlier result. We get 2 raised to 1 into 1 plus 1 by 3, 4 by 3 cos of 2k pi by 3 plus pi by 9. K values are, n value is 3, total number of roots are 3, therefore k value start from 0, 1, 2. Go on putting value of 0, 1, 2, we get 3 roots here as it is. Okay. Now consider next example. Solve x raised to 4 minus x cube. This is a very important example. Plus x square minus x plus 1. We can't factorize this equation. Okay, therefore we have to multiply both side by, this is the important step, this is the adjustment step. If alternating plus minus sign, there are only two examples of such kind. X raised to 4, x cube, x square, x and 1. Alternating plus minus sign. And other example I have given you as a homework, all plus signs are there. Okay, for these two examples just make one adjustment, multiply both sides by x plus 1. If alternating plus minus is there, we have to multiply both sides by x plus 1. If all plus signs are there, we have to multiply both sides by x minus 1. If multiply this way x plus 1, multiply throughout, all terms gets cancelled. Answer is only x raised to 5 plus 1. Okay. Now again solve this equation. X raised to 5 is equal to minus 1. X raised to 5 is equal to this. X raised to 5 is equal to minus 1. Therefore x is equal to minus 1 raised to 1 by 5. And rest of the term as it is, as we solved earlier in earlier example also. These are the 5 roots we get. Okay, the go on putting value of k is equal to 0, 1, 2 up to 4. We get this roots of this total root. 5 roots we get, and already we have original equation. Highest power of x is x raised to 5, and we multiply both sides by this factor, therefore we get 5 roots. But in original equation we have only 4 roots, and by this factor x is equal to minus 1. This is the factor. What is the root then? X is to minus 1 is we get extra root from this 5 root. This one is the middle extra root. Cos pi plus I sin pi's value is minus 1, root of this extra factor. And apart from this root, x1, x2, x4, x5 are the only roots, 4 roots of the original equation. Okay, what is the main step of this example? Just this, because we can factorize this equation. Just multiply both side by x plus 1. Now take this homework, solve same example as above. Just there is alternating plus minus in earlier example. Here all plus minus plus signs are there. Therefore we have to multiply both side by opposite factor, that is x minus 1, and solve as earlier. Same example. Okay. Now consider this example. We have to solve x plus 1 raised to 7 is equal to x minus 1 raised to 7. Solve means roots of this, we have to find out roots, and we have to show that roots are given by this plus minus I cot k pi by 7. K values are obviously k values are given 0, 1, 2, only 3. Okay, there are total 7 power. There are total 7 roots should be there, but here k values are only 0, 1, 2, 3, 4. Let us see. X plus 1 raised to 7 is equal to x minus 1 raised to 7. Take x minus 7 on this side, x minus 1 on this side, we get x plus 1 upon x minus 1. Raised to power is same, raised to 7 is equal to 1. Now x plus 1 upon x minus 1 is equal to 1 raised to 1 by 7. This is the 7th root of 1. Again apply same theory. 1 is replaced by cos 0 plus I sin 0 raised to 1 by 7 as it is, and add a 2k pi to this 0, and then 7 inside by De Moivre's theorem. K values are 0 up to 6, one number less than 7. Total 7 roots. Okay, now we know for simplicity we convert this complex number to into exponential form. Okay, because we know this is one result, that is e raised to I theta is nothing but cos theta plus I sin theta. This is one result. This is one result. Okay, we have to use this formula here. Therefore cos theta, this is your theta value, plus I sin theta is nothing but e raised to I theta. Theta value is, for simplicity we keep it as I theta. What is theta? 2k pi upon 7. Okay, now consider LHS is same, x plus 1 upon x minus 1 is equal to e raised to I theta. Now we have to find out x value from this equation. Therefore x plus 1, x minus 1 is there. There is one process that what is called component and dividend process. What is that process? This is numerator, this is denominator. Okay, we have to add denominator to the numerator and subtract denominator from this numerator. This is called component and dividend process. Both are the numbers are same. Like for example, suppose 1 by 2 is equal to 2 by 4, right? This is the equation, both are equal. 1 by 2, 2 by 4 cancelling, we get half is equal to half. Okay, what is component and dividend process? This numerator add denominator to this numerator. What we have to do? On both side, obviously this is a on both side. Numerator, that is 1, plus denominator, that is 2, divided by numerator, that is 1, minus this denominator 2. Apply on both sides obviously, which is equal to numerator plus denominator upon numerator minus denominator. We have to check whether this is equal or not. 1 plus 2 is 3 upon minus 1, which is equal to 4 plus 2, 6 upon minus 2. Answer is minus 3. Here also minus 3. Okay, this is called the component or dividend process. We have to use this in this equation. Therefore apply both side component or dividend process. We get x plus 1, this is numerator, x minus 1 is denominator. Here e raised to I theta is the numerator, and denominator nothing is there, that means 1 is there. denominator is 1. Therefore x plus 1 plus x minus 1 upon x plus 1 minus x minus 1 is equal to e raised to I theta plus 1 and e raised to I theta minus 1. Okay, now simplify this, we get numerator 2x upon this 2 is equal to e raised to this as it is. 2 gets cancelled, value of x is equal to this number. Okay, now what we have to do, one adjustment we have to do for these examples, multiply and divide by this factor e raised to minus I theta by 2. This is one adjustment to this example on both sides. What we get, e raised to I theta minus e raised to I theta by 2, value is e raised to I theta by 2. Okay, how come? E raised to I theta into e raised to minus I theta by 2, base are same, therefore e raised to I theta plus minus I theta by 2 is equal to e raised to I theta is common, 1 minus half, which is equal to e raised to I theta 1 minus half is half. Okay, this is e raised to I theta by 2 plus this again 1 into this is e raised to minus I theta by 2, this again e raised to I theta by 2 minus e raised to minus I theta by 2. Now again we have to use one result. We know cos theta is equal to e raised to I theta plus e raised to minus I theta divided by 2, and sin theta is e raised to I theta minus e raised to minus I theta divided by 2i. These are the two results we have to apply to this, where here theta is nothing but theta by 2. We have to just take 2 on this side, we get 2 cos theta by 2 in the numerator. Take 2i on this side, we get 2i sin theta by 2. Okay, now 2 gets cancelled, 1 upon I, cos upon sin is cot theta by 2. Again, when I, in any example, if I comes to denominator, we have to multiply and multiply numerator and denominator by I, so that it comes to numerator. Therefore multiply and divide by I, we get I here, here I square. What is I square? Minus 1 is there, and rest of the term as it is. This is minus I cot theta by 2, we get x value. Now put theta, our original angle, 2k pi by 7. Okay, now 2 gets cancelled, we get only k pi by 7. X values are ki minus I cot k pi by 7. Theta value is this. Okay, now go on putting values of k. We have total 7 roots. We get k is equal to 0, 1, 2, 3, 4 up to 6. First put k is equal to 0 in 1, we get x plus 1 upon x minus 1 is equal to 1, that is x plus 1 is equal to x minus 1, which means 1 is equal to minus 1, which is not possible. Therefore for k is equal to 0, we don't get any root, therefore we skip k is equal to 0 here. Okay, now comes to 1, 2, 3, 4, 5, 7, rest of the 6, let us say. Here we get x is equal to minus I cot k pi by 7. Values of k are now except 0, 1, 2, 3, 4, 5, 6. Okay, now put k is equal to 1, we get first root, x1 is equal to minus I cot pi by 7. Put k is equal to 2, we get second root, minus I cot 2 pi by 7. Third root, minus I cot 3 pi by 7. Now fourth root, minus I cot 4 pi by 7. Now we can use here one result, cos of pi minus theta is nothing but minus cot theta. Therefore we have to convert 4 pi by 7 into pi minus 3 pi by 7. Okay, this is 4 pi by 7 minus I as it is, cot as it is. 4 pi by 7 is nothing but pi minus this earlier root, 3 pi by 7. This is a technique, half roots are repeated after some time. These are the half out of 6. These are the 3 different roots, and more in every example, more than half roots or from half roots, the rest of the half roots are get repeated. Okay, therefore pi minus 3 pi by 7 is nothing but obviously 4 pi by 7, and we know this result minus cot 7. Therefore cot of pi minus theta is nothing but minus cot theta. Minus minus gets plus. Okay, and this is the same as this, just this plus, this is minus, therefore it is complex conjugate of x3. This is x3, complex conjugate of x3. Okay, that is complex conjugate, we denote it as x bar. This is a complex conjugate of this x3. Now put value of k is equal to 5 here. We get x5 is equal to minus I cot 5 pi by 7. Again replace it as pi minus this 2 pi by 7. Cross multiply, we get 5 pi by 7 here. Again use cot of pi minus theta is minus cot theta. Minus minus gets plus. Okay, this is again same as this x2. This is just plus and this is minus. Therefore it is complex conjugate of x2. Now put value of this is x2 bar. Put value k is equal to 6. We get x6 is equal to minus I cot 6 pi by 7. Again 6 pi by 7 is nothing but pi minus pi by 7. Okay, and again use this result. Cot of pi minus theta is minus cos theta. Minus minus plus cot pi by 7 is again a complex conjugate of this number x1. Okay, therefore these 3 roots we are getting as a x1, x2, x3 different roots, and these are just x1, x2, x3. These are complex conjugate of these numbers. Therefore one is plus, one is minus. Therefore total roots are x is equal to plus or minus. Okay, I cot k pi by 7, and values of k's are only 1, 2, 3. Okay, now consider next example. This is the homework. By earlier also using this example you can solve this example. X plus 1 raised to 6 and plus x minus 1 raised to 6. We have to solve as earlier, and show that roots are z is equal to this given z is equal to minus half plus minus I by 2 cot theta by 2. Theta value is 2k pi by 3. Solve as earlier. Okay, hint is given. This is as earlier. This is the hint as so we solved in earlier example only. Okay, now consider next example. We have to solve z cube is equal to this. Z cube is equal to z plus 1 raised to cube. We have to find out 3 roots. Okay, take z plus 1 on that side. We get z upon z plus 1 cube is equal to 1. Therefore z upon z plus 1 is equal to 1 raised to 1 by 3. Again apply root 3 here. Okay, as earlier theta is equal to 2k pi by 3. It is e raised to I theta. Again by component and dividend into process on both sides, we get z plus 1, z minus minus 1 minus z minus 1 is equal to this. And again proceeding as same as earlier this example, you get the 3 roots of this equation like this. 2z plus 1 is equal to upon minus 1 is equal to minus out I cot theta by 2. Apply the same procedure as earlier example. We have studied it in detail. We get minus I cot theta by 2, where theta value is 2k pi by 3. Therefore 2z plus 1 is equal to minus minus plus I cot theta by 2. Therefore 2z is equal to minus plus 1 gets on right hand side, we get minus 1 plus I cot theta by 2. Therefore z is equal to take half on this side, minus half plus I by 2. This we get proper answer.